Hello everyone, welcome back to my YouTube channel. So this week I'm going to explain to you how you should answer quiz 2 questions. So altogether we have 6 different questions and let's start with the first one. 1.750 gram of water that was just boiled loses 78.45 kilojoule of heat as it cools. What is the final temperature of the water when given that the specific heat of the water is 4.184 joule over gram degrees Celsius? The first thing that you need to look at is the unit that is being given to you. So from the specific heat of water, you can see that the unit given is in joule, gram and also degrees Celsius. So the mass given to you is in gram, that's fine, but the heat is given to you in kilojoule. So what you need to do now is to convert this kilojoule into joule beforehand. Alright, as we already know, 1 kilojoule, to convert to joule, you need to times 1000. So since you have 78.45 kilojoule, so you need to convert it to joule. So 78.45 kilojoule times 1000. So you should get 78450 joule. So this is the first step that you need to do. So what's next? You need to know what type of formula that you need to use to answer this question. So this question, the formula that is suitable for you to use is Q equivalent to ms delta T. Alright now, so what you need to do is you need to read back the question. So in the question it states that this amount of water which is just boiled loses the heat. So loses the heat means that your Q must be negative. So from the calculation that we have done just now, so because it loses the heat, so it must be negative. So from the calculation to convert from kilojoule to joule, we got 78450 joule of heat is equivalent to mass. So the mass is given in the question is 1.750 gram, and then the S is given in the question as well, so which is 4.184 joule over gram degrees Celsius, and then the temperature. So the change of temperature is the final temperature minus the initial temperature. So what is the initial temperature? So all of us know that this water is just being boiled. So you need to know what is the boiling temperature of water. So boiling temperature of water is equivalent to 100. Alright, so now what you need to do is you need to calculate what is your F. So first thing that you need to do is you need to times this one, this part you need to times first so that you can get the value of F. So after doing that, you should get 3138 F is equivalent to 235,350. Then you can do your F is equivalent to 235,350 divided by 3138. So your F should be equivalent to 75 degrees Celsius. But from the choice of answers given to you, the answer should be in Kelvin instead of degrees Celsius. So what you can do is 75 plus 273 to convert it to Kelvin. So you should get your final answer is equivalent to 348 Kelvin. So this is the final answer for the first question. Let's move on to question number 2. The reaction between nitrogen gas and hydrogen gas will produce ammonia gas. Decide if the reaction is exergonic or endergonic. Given that the delta H formation in kilojoule per mole for N2, H2 and also NH3 are 0, 0 and negative 46.11 respectively. Apart from that, the delta S in joule per Kelvin for N2, H2 and NH3 are 191.61, 130.68 and 192.45 respectively. In order for you to answer this question, the first thing that you need to do is you need to know how to write a balance equation for this reaction. So in this case, given to you is that the nitrogen gas is being reacted with hydrogen gas to produce the ammonia gas. So what you need to do now is you need to make a balance equation of this reaction. So if you can see here, in the product you have 3 hydrogen and in the reactant you have 2 hydrogen. So to balance this out, the part in the reactant you need to times 3 and the part in the product you have to times 2. Then you need to check back on your N. So your N in the reactant you have 2N, and now because you have already times 2, so you have 2N at the product as well. So this is the balance equation for your reaction. So next up, we are going to calculate your delta H. So in your delta H, the formula is the summation of delta H of the product minus the summation of delta H of the reactant. So now you can see here, this part is your product and this part is your reactant. So what we are going to do is that we look at the product. So you have 2 NH3, so 2, and then you go and find the delta H for NH3 is equivalent to negative 46.11, and then the summation of delta H of the reactant, both are 0, so 0 plus 0. So you should get, your answer will be negative 92.22 kilojoule per mole. Alright, so now what you need to do is look at what is the unit for the other information that is being given to you. So here, you can see that in your delta S, the unit is in joule instead of kilojoule. So since when you calculated, you already calculated in kilojoule, so you need to convert this into joule. Right, so this is in kilojoules, so we want to convert it into joule. So all you need to do is you need to times with 1000, because 1 kilojoule is equivalent to 1000 joule. So at the end you should get negative 92220 joule. Right, so you can write joule per mole or you can just write in joule. So that is your delta H. Okay, next up we are going to calculate the delta S. So delta S is almost the same, is the summation of the delta S product minus the summation of delta S reactant. Alright, so the same drill, you are going to look at this one as product and this one as the reactant. So you're just going to look at the value given in the question and plug it in. So by referring to the values that is given to you in the question, so you should be able to calculate the delta S should be equivalent to 3.8490 times 10 to the power of 2 minus 5.8365 times 10 to the power of 2. So you shall get your delta S is equivalent to negative 1.9875 times 10 to the power of 2 joule per Kelvin. Right, this is the second step that you need to do for this question. Alright then, Now we already know that our delta H is equivalent to negative 92.220 joule and your delta S is negative 1.9875 times 10 to the power of 2 joule per Kelvin. Alright, let's look at what are other information that is given to you in the question. So it states here that the reaction is conducted at 125 degrees Celsius. So now you can actually calculate what is your delta G. Alright, now let us calculate what is your delta G. So delta G is equivalent to your delta H minus T delta S. So make sure that your T is in accordance to the unit with your delta S. So your delta S, the unit for the temperature is in Kelvin, so you need to convert it to Kelvin instead of just using it in degree Celsius. So you're going to just plug in all the values that you have calculated just now. So your delta H is equivalent to negative 92220 minus your T is equivalent to 398 times your delta S is equivalent to negative 1.9875 times 10 to the power of 2. Right, so all you need to do is just press your calculator and you should get your delta G is equivalent to negative 1.31175 times 10 to the power of 4. So if you can see here, your delta G is negative, right? Your delta G is negative. It means that your delta G is actually less than 0. Okay, according to the theory, you need to always remember that when your delta G is less than 0, it means that this reaction is exergonic. Alright, so this is the final answer for your second question. Moving on to question number 3, what is the minimum temperature would a given reaction become endergonic when given that the delta H is equivalent to 133 kilojoule and the delta S is equivalent to 401.5 joule per Kelvin? So we are going to do the same drill. We need to look at the unit. So for your delta H, given to you is in kilojoule, whereas for your delta S given to you is in joule per Kelvin. So it means that you need to convert the kilojoule into joule. Right, since you know that from kilojoule to joule you need to times 1000, then your delta H is 133, so 133 times 1000. So you can convert it into joule, so you shall get 133,000 joule. Alright, next up, we need to know what is the temperature that is a specific temperature that you need to meet in order for this reaction to be endergonic. So how we're going to do so is you need to know that when it is an endergonic reaction, so you need to know that your delta G must be bigger than 0. Then only it will be considered as endergonic reaction. In this type of question, you need to be very specific on the temperature itself. So all you need to do is you need to at least calculate your delta G. So your delta G is actually equivalent to delta H minus T delta S. So now we just need to assume your delta G is 0 because then only you can know that what is the temperature that you need. So since you already calculated the conversion from kilojoule to joule, so you have your delta H is equivalent to 133,000 minus T, the thing that you want to calculate, and your delta S is 401.5 joule per Kelvin. Therefore, you can say that your T is actually equivalent to 331.2577 Kelvin. Okay, this is the first step that you need to do in order for you to determine what is the minimum temperature. So now, since you already know what is the temperature, the exact temperature that you need to look at, so you need to decide whether to get delta G bigger than 0 must be bigger or smaller than the value of your T. So this is the value of your T that you are looking at, so you need to decide which one, so whether it should be bigger or smaller than 331.2577 Kelvin. So what you can do is you can do try and error. So for example, if you were to get delta G bigger than 0, would you rather use a bigger value than 331 or smaller value than 331? In this case, supposedly you should be using temperature that is lower than 331.2577 Kelvin. So let's just check whether this is correct or not. So we are going to calculate back the delta G. So delta G is equivalent to delta H minus T delta S, right? So we are going to use the same value of delta H, which is 133,000 minus T. So your T, because we said that it should be lower, so I will assume as 200. And your delta S is the same also, is 401.5. So from here, when you calculate, you will get your delta G is 52700. So in saying that 52700, your delta G is actually bigger than 0. So it's proven that the temperature should be lower than 331.2577 Kelvin. Let's move on to question number 4. A gas cylinder contains 4 times 10 to the power of 4 centimeter cube of hydrogen gas at a pressure of 2.5 times 10 to the power of 7 Pascal and temperature of 290 Kelvin. The cylinder is to be used to fill some balloons. Each balloon, when filled, contains 7.24 times 10 to the power of 3 centimeter cube of hydrogen at pressure of 1.85 times 10 to the power of 5 Pascal and the temperature of 290 Kelvin. So determine the number of balloons that can be filled from the cylinder. In this type of question, the first thing that you need to do is you need to look at all the unit that is given to you. So the unit here is in centimeter cube and also Pascal and Kelvin. So the Kelvin part is okay, but the centimeter cube and also the Pascal, you need to make sure that you need to convert all this unit into the proper unit, which is liter and also ATM. So I'm just going to go briefly on the conversion. So the 4 times 10 to the power of 4 centimeter cube is actually equivalent to 40 liter, and the pressure 2.5 times 10 to the power of 7 Pascal should be converted to ATM, which is equivalent to 246.7925 ATM. Right, so we are going to do the same drill for the other part of the question. So you need to convert the 7.24 times 10 to the power of 3 centimeter cube, so into liter. So you should get 7.24 liter, and the pressure is 1.85 times 10 to the power of 5 Pascal. So here you should get 1.8263 ATM. So these are just the unit conversion that you need to do beforehand. Then only you can do the calculation. So now you need to understand that we have two different condition and two different things that you need to look at. So the first thing is you have this cylinder full of gas. So it means that all these gases is going to be transferred into few balloons. So you need to know what is the number of mole for the gas in the cylinder itself. So in order for you to find the number of mole or how much gas is there in the cylinder, you need to use the ideal gas law. So the ideal gas law is equivalent to PV equivalent to nRT, right? So after the conversion from the Pascal to ATM, so you get your pressure is actually 246.79 to 5, and then your volume is 40 liter. N is the thing that you need to calculate, and R is actually the constant unit, which is 0.0821, and your T must be in Kelvin, 290. So from here we can say that your N is actually equivalent to 9871.7 divided by 23.809, and you will get your N is equivalent to 414.6205 mole of gas. Right, these are the amount of gas inside the hydrogen tank, right? So now what we need to do is we need to determine what is the amount of gas needed in each balloon. So we can use the same formula, PV equivalent to nRT. So therefore, from the question, we can say that the pressure is equivalent to 1.8263 and your volume is 7.24. is equivalent to N, which is a thing that you need to calculate, and your R is a constant value 0.0821, and your temperature is 290 Kelvin. So from here you can calculate your N is equivalent to 13.2224 divided by 23.809. Therefore, your N is equivalent to 0.5553 mole. That is the amount of gas that is needed to fill in this balloon. Had been done, we know that the amount of gas in the cylinder is this much, and the amount of gas needed to fill in each balloon is this much. So we can say that for one balloon, so 0.5553 mole you can fill in one balloon. But how much do you have? You have this much, right? So 414.6205 mole equivalent to how many balloons? So 1 over 0.5553 times 414.6205. So supposedly you should get 700.5890. So basically what you can the amount of balloon that you can fill is just 746 balloon and not 747 balloon, because you don't have enough gas to fill another one balloon. So make sure that you choose the right answer. The final answer is actually 746 balloon only. Let's move on to question number 5. Two containers A and B are joined by a tube of negligible volume. Both containers are filled with an ideal gas at pressure of 2.3 times 10 to the power of 5 Pascal. Container A and B have volume and temperature of 3.1 times 10 to the power of 3 centimeter cube, 4.6 times 10 to the power of 3 centimeter cube, 17 degrees Celsius and 30 degrees Celsius respectively. Determine the total amount of gas in mole in the container. So we are going to do the same drill. The first and foremost, you need to look at the unit that is given to you. So the pressure given to you is in Pascal, volume in centimeter cube, and the temperature is in degrees Celsius. So we need to convert all of this unit to the specific unit that we need, right? So we are going to start with the pressure. If you can look at the question, the pressure for both containers are the same, which is 2.3 times 10 to the power of 5 Pascal. So you need to convert this to ATM. So you shall get is equivalent to 2.2705 ATM. Alright, next up we are going to convert all the volumes. So we have two different volumes because we have two different containers. So for container A we have 3.1 times 10 to the power of 3 centimeter cube. So from centimeter cube you want to convert to liter. So you divide it with 1000, so you get 3.1 liter. Same goes with the other container. It is 4.6 times 10 to the power of 3 centimeter cube. So it's equivalent to 4.6 liter. So now we are left with the temperature. So the first one is 17 degrees Celsius. So 17 plus 273 is equivalent to 290 Kelvin. And the other one is 30 degrees Celsius plus 273. So you should get 303 Kelvin. So all of these are in the correct unit already. Then we can move forward to the calculation. Right, so we are going to start with the calculation for container A. So in order for you to find the number of mole, you need to use the ideal gas law, which is PV equivalent to nRT. Right, so for container A, your pressure is the same as container B, which is 2.2705 ATM, and the volume is 3.1, is equivalent to N, the thing that you want to calculate, and R is a constant value, which is 0.0821, and your T is, the first one is 17 degrees Celsius, so is 290 Kelvin. So from here, you can get your N is actually equivalent to 7.0386 divided by 23.8090. Hence, you shall get your N is equivalent to 0.2956 mole. This is for container A. Alright, moving on to container B. So the same formula, PV equivalent to nRT. The pressure is still the same, 2.2705. Your V is 4.6. N is the thing that you want to calculate. R is the constant value, 0.0821. And your temperature is 30 degrees Celsius. So you get 303 Kelvin. Right, from here you shall get your N is equivalent to 10.4443 divided by 24.8763. Then you shall get your N equivalent to 0.4198 mole. Alright then, so from our calculation, we already know that container A and B, the number of mole are such. So when you want to calculate what is the total amount of gas, so total amount of gas in mole, right? So you just have to do the summation of the number of mole for container A and B. So what you need to do is that you need to add on to 0.2956 plus 0.4198, so it should be equivalent to 0.7 154 mole. So this is the total amount of gas in mole in both containers. We have now arrived at the final question for the quiz. The reaction where hydrogen gas and molecular iodine reacted, 3 mole of hydrogen iodide shall be produced. The Kp of this reaction is equal to 944 at 298 Kelvin, while at 427 degrees Celsius, the Kp is equivalent to 55. Is the production of hydrogen iodide favored more at higher or lower temperature? If we look closely at the question, you were given the value of Kp. So one Kp is 944 and the other one is 55. So according to the theory, if the value of your Kp is bigger than 1, means that this is a product favored reaction, means that it is prone to produce the product. So in the question, is the production of hydrogen iodide favored more at higher or lower temperature? So what you need to do is you need to compare which one of these have the higher Kp. So you have 55 and also 944. So obviously 944 is the product favored, means it have a bigger Kp. So now let's us compare between the temperature. So since that we have two different temperature, so the easiest way is to convert one of those. So I'm going to convert the one in degree Celsius. So you have 427 degrees Celsius plus 273 is equivalent to 700 Kelvin. So at 700 Kelvin, the Kp is 55, but at 298 Kelvin, the Kp is 944. So it is obvious that the bigger Kp is when you are using the lower temperature to undergo this kind of reaction. So the production of hydrogen iodide favored more at lower temperature. Thank you very much for watching this video. That's all for this week. See you again next week in my lectures and also a new video. So take care and stay safe. Goodbye.